Hey yo! All right. Today we've got homework for 522. So it starts off with this super fun problem. 536, 5-36. And it says it is the end of the semester. Pretty close to where we are right now. And the clubs at school are recording their profits. The science club started out with $20 and it's increased its balance by an average of $10 a week. Math club, math, has saved $5 per week, and it started out with 50 at the beginning of the semester. So we have to create an equation for each club and say which one's which. So let's start with science. So our science club, right? It told us that they started out with $20. That means that was their starting point, right? So if we were going to write an equation, y equals, we know that their growth was not given to us yet, so we're just going to leave that blank, something x plus 20, because that's how much they started with. It increased by $10 a week, so that would mean that the 10 is their growth. So their equation for science, y equals 10x plus 20. For math, which we all know is way better, that's science, y equals, they save $5 per week. So every week they're growing by 5. That is their growth. 5x plus, they started out with $50. Yeah. All right. Then for B, we need to graph both lines on the axes to see where the clubs have the same balance. All right. I chose to do the positive region because money is positive, so it makes sense, right? So let's start off with the science club. They started with $20. I chose to go up by 5s on my y-axis. You choose whatever you want. On the bottom, I went by 5s as well. I just kind of numbered it a little bit differently. I skipped every other line. So anyways, science club, they start with $20. So find 20, put a point there, right? They're growing by $10 every time. So I'm going, what am I saying? Oh, I'm going up 10, so from 20 to 30, right? And that would be in 1 week. So their point would be probably right about there. Why did I go by? I feel like I could have just gone by 1s at the bottom. I'm going to do that because that gets really weird otherwise. So, okay. Let's just cross all of that out. I don't know why I was going to go by a bigger number. That doesn't really make sense because it's weeks. So 1 week, right? I'm just going by 1. So then it would be 2, and then 3, and then 4, and so on and so forth. All right. So they started with 20. Then they, in their first week, went up 10. So they would go up to 30 and then over for 1 week. Then the next week, right, they're going to grow by another 10. So up to 40 and then over 1. Next week, another 10 over 1. Right. And it just keeps going. I'm just going to extend it a bit so that we can kind of get a good idea here. All right, so we can kind of generally see. We might have to extend it more later. We'll see. But that's the general line. Now, the math department, or math club, they started with $50. So find your 50 on your Y. They start with 5. They're only going up by 5 every time. So that's why I numbered it with 5. So over 5 for 1 week. Over 5 for the next week up 5 over, up 5 over, up 5 over, up 5 over. They both are going to intersect right at that point that I just left off at. That's nice. So I'm going to keep going just so that I can kind of see the true line here. And you can kind of see the line. All right, that should be enough for math. All right, and then science, they were going up $10 a week. So 2 and then over, up 2 and over, up 2 and over, at least if you numbered your line like I did. Now we can kind of see that they actually do intersect like that. And we can see the point of intersection, right, is that point right there. So when it says, when do both clubs have the same balance? Well, let's see. If we go over 1, 2, 3, 4, 5, 6 weeks, then we go up, that's that point. So after 6 weeks is when they have the same amount. Okay. What is that balance? Well, if I look at my point and I come over, I can see that I'm at $80. So their balance at that point would be 80. All right, number 37. Algebra tiles are back, right? Some of you might like that. Some of you probably are like, no. Anyways, all right, we have to find the area of the entire rectangle and the sum of the area of the algebra tiles. Okay, for part A anyways. So to find the area, that one's actually not too bad because we can just list the tiles that we see. So I see an x squared. That's the area, x squared. Then I can see I have some x tiles. How many x's do I have? Well, let's count them. 1, 2, 3, 4, 5, plus 5x. How many unit tiles do we have? 1, 2, 3, 4, 5, 6, plus 6. Guess what? That's the area. That's not so bad. Now, on B, though, and unfortunately, B printed on the other side, so I can't even flip the page right now. B unfortunately printed up here, so I'm going to do the work on the other side just so that we can see the actual picture because you're kind of going to need that, and then we'll write our answer on this side. Okay, so for the perimeter, we are going to need to say what all the side lengths are for these. We know that an x squared is an x by x, right? X times x, because that would be x squared. Now, our x tiles here, the length of them is x, but the width is just a single unit tile. Unit tiles have side lengths of 1. All right, again, the x tile, the length is x, the width is 1. So 1, 1, 1. Okay, now all we have to do to find the perimeter is add them all up. So how many x's do we see? Well, 1, 2, 3, 4. So let's see, I'll write it over here and then I'll put it on the other side at the end. 4x plus, now how many unit tiles do I have? Well, or units do I have around the outside? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4x plus 10 will be our perimeter. So I'm just going to write that actually next to the problem too so that I don't forget. The work obviously is on the other side though. So if this was on a homework check, you would need to show the work that you showed on the other side. Okay, 4x plus 10. Ta-da! Now, problem 38 says on our graph paper, right there, we have to plot these 2 points and draw a line through them. Then we need to create an xy, find the xy intercept of these 2 points. Okay, so step number 1, get your graph labeled like I did. I just went by ones every time. Step 2, we need to graph our points. So the point -3, 7 means I start at my 0, right? I come over to the -3 and then up 7. 1, 2, 3, 4, 5, 6, 7. Why do I count out loud? I don't know, because I need to in order to keep track. And then this point to -3, I come over to in the positive region and down 3 because it is a -3. 1, 2, 3. Just like that. If I were you at this point, I would use my ruler. I do not happen to have one, so I'm just going to kind of estimate it, but you should use a ruler. Okay. That's pretty close. All right, so then it said that we needed to name the x and y intercept. Well, that means the points where it is touching, and my line is not perfect. I wonder if I can get it. I'm going to try and use my phone. Maybe that'll help me get like a straight line. Slightly better, I don't know, maybe. Anyways, it's not perfect right here. So our y-intercept, we can see it's touching here at the y at number 1. So our y-intercept is going to be, the point would be 0, 1. Now the x-axis is not quite, for the y-intercept, is not quite as nice. It's kind of cutting through half of this point, right? So our x-intercept is actually going to be 1/2, or you could say 0.5, that would work too, 0, because we're not moving up or down at all. All right, so that is both this point right here and this point right there. All right, for the last, well, second to last one, right? Yeah, ish. Okay, 39. A local restaurant offers dim sum lunch special. Hopefully I'm pronouncing that right. That includes 2 dumplings, 3 egg rolls, a sweet bun, and a drink. Susan and her friends ordered 4 dim sum lunch specials. How many of each item should they receive? Okay, so basically we have Susan and her friends are going to order this. Let's see. Oh, they ordered 4 altogether, so plus 3 friends, right? So if there are 4 orders total, how many dumplings should we have? Each order comes with 2, so 2 times 4 we know is 8. So we should end up with 8 dumplings. We're just basically multiplying each of these by 4. 3 egg rolls, 3 times 4 we know is 12, so we should have 12 egg rolls. Sweet buns, each one just came with a sweet bun, so 1, so each one should have 1, so 4 of those. And then a drink, again, 4 of those, right? Everyone gets a drink. Hopefully that wasn't too bad. All right, on to the back side. Now we have to solve for x, and we need to show our work. If you remember a couple homeworks ago, we had problems that were similar to this where we were adding fractions and they didn't have the same denominator. Might help if you could see it. Okay, so we need to figure out a common denominator between 2 and 5. Obviously, there's not something I can multiply by 2 to give me 5. So I'm just going to use the common multiple between these, which is 10. So in order to do that, I'm going to multiply both the top and the bottom by the same number. And in order to get to 10, I need 2 times 5 will give me 10. So I'm multiplying by 5 on both the top and the bottom. 2 times 5. Okay, so when I multiply 5 times x, that will give me 5x. And then again, 2 times 5, we said what, or 2 times 5, yeah, is 10. Oh, going so fast. Okay, so this fraction is equivalent to this one right here. Okay. All right, next one, right, the second fraction. X over 5. Oh, yeah. Okay. So what do we have to multiply by? 5 to give me 10, 2. So I have to multiply the top also by 2. So 2 times x is 2x, and we said 5 times 2 is 10. So this fraction is equivalent to that one right there. All right, so essentially I'm just going to rewrite it because so it looks a little bit neater, but we have 5x over 10 plus 2x over 10. Now, do you see how we have the same denominator? Now we can actually add these, and we were told that it equals 1. So when we go ahead and add this, 5x plus 2x we know is 7x divided by 10 equals 1. Now we're asked to solve for x. So right now we're dividing by 10, so we need to do the opposite of that, which is to multiply by 10. This is a multiplication sign, not a decimal. I just didn't want to use x because that gets even more confusing. So we're left with 7x equals 10 times 1 is 10. Then in order to solve for x, we know we need to divide by that coefficient of 7, that number out front of x. So 7 divided by 7 is 1, which means we have x equals, I'm just going to leave this as a fraction because it's not a nice number. So I'm just going to leave it as x equals 10 over 7. Just like that. Alrighty, one more to go. Letter B. Ooh, you might look at that and go, I don't know what to do. Well, first we need to get common denominators, right? 3 and 4, we can't add those two fractions, so we need to get a common denominator between the two of them. So I know that 3 times something and 4 times something will get me to 12, so I can use that as a common denominator. 3 doesn't go into 4, like there's nothing I can multiply by to get me to 4, so we'll just use 12 as a common denominator. So what do I need to multiply by 3 to give me 12? Well, that would be 4. So whatever I do to the bottom, I need to do to the top, which means that I now have 4x over 12. Okay, so that's this fraction. I try and draw the arrows just to help me keep it all straight. And then we have x minus 1 over 4. And we know that we need to multiply 4 times 3 to get me 12, so I have to multiply by 3 up top as well. And when we do that, we have 12 again on our in our denominator. And then we have 3x, right? When I multiply 3x minus 3, right? Because 3 times x, 3 times negative 1. All right, so here is my fraction for this side. All right, then I'm going to go ahead and rewrite all of this to make it look a little bit nicer. Let's just do a squiggle line so we can see our work. All right, so we have 4x over 12 plus 3x minus 3 over 12 equals 2 plus x. Alrighty, so now that we have that, we can go ahead and combine some like terms here. So 4x and 3x, we can add those to get 7x. Minus 3 stays the same. Divided by 12 stays the same. 2 plus x, just like that. All right, so now in order to get rid of this denominator, I know that it's being divided by, so I'm going to do the opposite. So multiplying by 12 on either side. All right, so that will leave me just with a 7x minus 3 on the left. And then when I go ahead and multiply, right, 12 times 2 is 24. And then plus 12 times x is 12x. We have to remember to multiply both numbers, or both things, by 12. All right, and then it's just a straight solving for x kind of situation. So I'm going to start by subtracting 7x on either side to kind of get it over onto this side with the other x's. So that means I have negative 3 equals 24 plus 12 plus 7 would be 19. X, just like that. And then, let's see. Did all that. Okay, now we need to move the 24 over, right, by subtracting by 24 on either side, minus 24. So negative 24 plus negative 3, negative 27 equals 19x, just like that. And then, okay, and then I would need to divide by 19 on either side to get x by itself, right, because that's that coefficient, which leaves me with a really fun fraction of negative 27 over 19, which I'm just going to leave like that because that is a messy decimal, so I'm just going to leave it in fraction form. It is negative, though, which is why I kind of erased it and made it look a little bit better. All right, hopefully that makes sense. If you have more questions, let me know.